let's now have a look at the chemical reactions of ammonia. The first one being reaction with oxygen. So what happens when we react ammonia with oxygen? The product that we get are nitrogen gas and water. But when you do the same reaction in the presence of platinum catalyst at 1100 Kelvin, that is 1100 Kelvin, we get nitric oxide, that is NO, and steam, that is H2O. Now when we do oxidation of this ammonia using CuO, that is copper oxide, in the presence of heat, what we get is copper and water, and we get nitrogen gas. Moving ahead, this aqueous solution of ammonia is weakly basic. Why? It is because of the ionization of OH minus ions. That is, when I take ammonia and we put it in water, what we get is NH4 plus and OH minus, that is ammonium ion and hydroxyl ion. Also, ammonia undergoes self-dissociation or self-ionization in liquid state and acts as a solvent. This ammonia dissociates itself to give NH4 plus and NH2 minus. Going ahead, now actions of halogens on ammonia. First, we will have a reaction with chlorine. So 8NH3 when reacted with 3Cl2. When we compare the stoichiometry, what we can see that ammonia here is in excess. So they react to give us ammonium chloride and N2 gas. But when they turn the tide, that is when we take chlorine in excess, the products that we get are completely different. What we get is NCl3, that is nitrogen trichloride, followed by HCl. Similarly, when we do the reaction with bromine, in this case we take ammonia in excess again, and similarly like chlorine, what we land up with is ammonium bromide, that is NH4Br and N2 gas. Moving ahead, we'll have a look at its reaction with iodine. So NH3 plus I2, it gives us NH3Ni3, which is nitrogen triiodide ammonia, and 3HI. This NH3Ni3 further decomposes to give N2I2 and 6NH4I, that is ammonium iodide. Moving ahead, now have a look at its reactions with metals. So if I react sodium with ammonia, the product that we get is at 575 Kelvin is NaNH2 and H2 gas. This NaNH2 is called as sodamide. Further, when ammonia is reacted with NaOCl, that is sodium hypochlorite, in the presence of gelatin, we get NH2NH2, that is hydrazine, followed by NaCl and water. Then we have a look at reaction of ammonia with a white precipitate of AgCl. Now we take white AgCl, which is a white precipitate. To that we add ammonia. As a result, we get a coordinate compound, that is AgNH3 twice Cl in the aqueous state. Now AgCl is a white precipitate, and when we add ammonia, what happens to the color of the reaction? Let us check. So we have AgCl, and now when we add ammonia, it turns colorless. So the coordinate compound that we got is colorless. Similarly, another reaction is reaction of ammonia with copper sulfate. Now when you take CuSO4, which is a light blue colored solution, when you add ammonia to this, it also gives a complex, that is CuNH3 4 times SO4 aqueous, and this is indeed a beautiful reaction to look at. This complex formed is dark blue in color. So using this and the previous example, we can prove that NH3 behaves as a ligand. Now moving ahead, reaction of ammonia on Nessler's reagent. Now how do we prepare Nessler's reagent itself? For that, what we do is we take HgI2 mercury iodide, and to that we add Ki potassium iodide. What we get is K2HgI4 aqueous. This K2HgI4 is called as the Nessler's reagent. This Nessler's reagent is actually used for the detection of ammonium ions, that is NH4 plus. So what we do is we take ammonia along with Nessler's reagent and treat it under basic conditions, that is we add KOH. This results in the formation of something called as iodide of Million's base, that is NH2HgO-HgI along with Ki and H2O. This is very important, the iodide of Million's base. This iodide of Million's base has a specific brown color. So as soon as we get a brown color or a brown precipitate, when we add Nessler's reagent to a substance, that substance for sure contains ammonium ions. It's time for some MCQs now. The first one that we have is catalytic oxidation of ammonia gives. For that we'll have to look at the reaction. The second reaction that we see here contains platinum and it is the catalytic one. So the product which we got here was NO, nitric oxide. So the correct answer is option B, nitric oxide. The next question that we have here is ammonia reacts with bromine to form. We have our 4 options here and we have seen this question already. So 8NH3 plus 3Br2 giving us ammonium bromide, that is NH4Br. So the correct answer is option C, that is N2 and NH4Br. The next one that we have here is Nessler's reagent is used for the detection of. While we were studying this part, I told you that this is used for the detection of ammonium ions, and ammonium ions are option A, NH4 plus ions. The next question that we have in line is ammonia is a Lewis base. It forms complexes with cations. Which one of the following cation does not form complexes with ammonia? Now our 4 options are Ag2 plus, Cu2 plus, Cd2 plus and Pb2 plus. Now Cu2 plus and Cd2 plus, both of them are D block elements, and we have seen the reaction with Ag and we have also seen its reaction with Cu. So, and if Cu gives the reaction, Cd will also give the reaction. So the one which does not give the reaction is option D, Pb2 plus, that is lead ion.